This next unit that we'll be playing with is about momentum. And we're going to start combining some ideas um, about mass and speed and velocity and a lot of other things. And we're going to roll them into this idea of momentum from a physics point of view. So when you hear the word momentum, what are you thinking? Okay? You hear sportscasters talk about momentum. You hear, all kinds of people talk about momentum. But what is it that we're looking at? You can call it inertia in motion, okay? And it's the tendency of an object to keep moving, okay? And this goes back to Newton's days when he was first thinking about things. An object in motion stays in motion until acted upon by an outside force. So there's this tendency for an object, once it's moving, to keep moving. Well, how do we measure that? Well, inertia in motion. Inertia, how do you measure inertia? Maybe it has something to do with mass. And motion, that means we have to start talking about maybe velocity, okay? Whoa, this one didn't come out well at all. So which object do you think has more momentum, a car or a train? Well, if they're going the same speed, the train has much more mass. It's harder to stop a train than it is a car. It's harder to get a train going versus a car. Okay? So when does the roller coaster have the most momentum? Okay? Going 50 miles an hour or 70 miles an hour? Well, if it's the same train, probably it's 70 miles an hour. Okay? What two factors affect momentum? Well, we're talking about, like we were talking about at one of the first pages, your mass, remember, your mass measures inertia. That's going to be measured in kilograms, okay? And then we'll primarily deal with velocity here, and we'll get into meters per second, okay? We need these two factors in order to measure momentum. Okay, so it's mass times velocity, and they use the Greek letter rho. Okay, it's kilograms. The unit is going to be kilograms meters per second. The physics people didn't come up with a special unit. This is kind of a derived type of a thing, right? Mass has its own unit, velocity has its own unit. So when we combine them, we have to derive this, and here we are at kilograms meters per second. And again, things for a comparison point of view, you need to look at a velocity, you need to look at a mass. Now we have this idea of an impulse. Newton's first law, an object in motion stays in motion until acted upon by an outside force. Well, in order to change your momentum, you have to exert a force on whatever's moving. Okay? It's called impulse. We apply a force over a period of time. Okay? It's basically what we need to do, Newton's first law, until acted upon by an outside force. This is the outside force right here. Okay? That's what we need to look at. So you also have to, if you're going to change momentum, you have to provide an impulse. So what do you know then about a momentum change and impulse? What do you think those two are going to come out to be? Well, there's some equations in here and some equalities in here. Remember, this stuff isn't random, okay? Everything seems to be related. So the impulse of an object is equal to the change in momentum, right? You don't get something for nothing. Here's your impulse. This is m delta v here. I don't know what that little box came out to be, okay? So the impulse is a change in momentum. Or if you look, whoa, where'd it go? I don't know. What you look for then is your impulse is what? Your force times a change in time, or simply force times time. What does that have to equal? That is mass times a change in velocity. Okay? Some things you have to keep into consideration here. Your change in velocity, remember, that's a vector quantity. That has a direction associated with it. So you're going to have to, if you're going two different ways, when you're calculating these things, you're going to have to make one positive and one negative. Okay? So F delta T equals M delta V. And remember, your change in velocity is simply going to be V final minus V initial. Okay? Forces are simply going to be measured in newtons. Time is measured in seconds. Your mass has still got to be in kilograms. Okay? This rolls into our next unit when we get into about collisions. Okay? Because things change. Obviously, when you have a collision, there are forces involved. And we'll show you how all of this fits together. Okay? But right now, this is called the impulse momentum theorem, right? F delta T equals M delta V. Force times time equals mass times a change in velocity. How much did your velocity change because of that applied force? Okay? I think that's it. I think so. Thank you very much. We'll pick up again in a little bit. Bye.